Hi everyone,
Welcome to Smart Classroom.
this is Mahammood Suhail Mundodan.
Welcome to next lecture. Today's lecture is the continuation of the topic we discussed last. That is the concept of electric field. How many number of field lines are there? The answer is infinite number. But here considering only few of them for clarity. The plus charges blow out the air like an air dryer, and the minus charges sucking the air like a vacuum cleaner. The field strength. If the field lines are closer together, then the density of the lines are high. When we move away from the charge, the density is going down. Far away, the electric lines are going down by 1 by r square. Now consider the electric field. In a straight electric field, if we release a charge plus q there, then it experiences a force exactly in the same direction of the electric field. It will become accelerated in this direction and stay on the field lines. When we release with zero speed and start to accelerate and stay on the field lines. In a similar way, if we think that the earth has a gravitational field, when we release a ball with zero speed, then it begins to move in the direction of the field and stay on the field line. If we release a charge, will it always follow the field line? The answer is no. Only in the very special case, like a straight electric field. Suppose the field line is curved. Then if we release a charge at this point, it experiences a force. At P1, the force is along the field F. Every field line, the charge experiences a force. The force at this point P1 in this direction. When it reaches at this point P2, the force will be in this direction. The motion of the charge in this field is very complicated. Now you see, this is the trajectory of the charge in this field. The white colored line represents the trajectory of this charge. Next topic, the field configuration of the positive and negative charges. If the charge is plus 4 and plus 1, then the arrows are pushed outward. If the charges are minus 4 and minus 1, then the arrows are inward. If we put a positive charge in between plus 4 and plus 1, then plus 4 repel it, plus 1 also repel it. Some probability close to plus 1, the two forces are exactly cancelled out. Therefore, electric field will be zero there. In similar way, between the moon and the earth, the point not far away from the moon where the gravitational attraction from the moon and the gravitational attraction from the earth exactly cancel each other. The next topic, electric dipole. Now we will take a special case. If we take two charges equal in magnitude and opposite in sign, we have a name for that, dipole. If we are very far away from the dipole, then we have a problem. In the case of plus 5 and minus 1 charge, at far away, it looked like a plus 4 charge. But in the case of a dipole, in far away, you do not see any arrows, either pointing out or pointing in. That means when you move away from the electric dipole, then the electric field fall off faster than 1 by r square. If you are far away from the dipole, the electric field is fall off by 1 by r cube. Next topic, how to produce electric dipole. Here we have two metal spheres supporting on insulating stand. Two spheres are touching each other. When the rod brings near to the sphere 1, the free electron in the sphere 2 are moved to sphere 1. This leaves an excess of positive charge to the surface of the sphere B. Now we separate the sphere by a small distance while the glass rod is still held near the sphere 1. You can see that the sphere 1 become negatively charged and sphere 2 become positively charged. Now the two spheres are found to be oppositely charged and attract each other. If we remove the rod, the charges on the sphere rearrange themselves. Now we separate the sphere quite apart. The charge on them get uniformly distributed over them. In this way, I have created positive charge on sphere 1 and negative charge on sphere 2. Sphere 1 and 2 have the same charge of equal in magnitude and opposite in direction. So we created a dipole. Next topic, effect of dipole in an electric field. When a dipole is placed in an electric field, then the dipole starts to rotate. How it is happening? Consider an electric field and bring a dipole into that electric field. Positive charge experience a force along the direction of the electric field, and negative charge experience a force in the opposite direction of the electric field. Due to this combined force in opposite direction will experience a torque on the dipole and it start to rotate in an electric field. Next we will see a demonstration. In this demonstration, I will show you the movement of a charged object in an electric field. This is Van de Graaff generator. It is an electrostatic generator which is used to produce static charges at higher level for physics experiment. You see the suspended sphere oscillating back and forth between two shells. Can you guess what is the reason? We will see. Here we have three semi-spherical conducting shells. The central shell is connected with positive terminal of Van de Graaff generator and other two shells connected with the negative terminal of the Van de Graaff generator. When I switch on the power, the positive charge will accumulate on the central shell and the negative charge accumulate on the other two shells. Because of induction, the suspended conducting sphere attracted towards the negatively charged shell. Once it touches the shell, it becomes negatively charged and attracted towards the positive shell. If it touches the central shell, it becomes positive again. This process will continue and the sphere will bounce back and forth between two shells. In this way, we can make fun with physics. That's all for today. If you have any doubt regarding this topic, comment under the comment section.
If you like this video, please subscribe and share. To get all our notifications and updates, don't forget to press the bell icon. Thanks for watching. See you next time.